Here's a quick example on how to use synthetic division with polynomials. So we're looking to divide this larger polynomial, 3x to the fourth plus 3x to the third plus 7x squared minus 7, by the binomial x plus 1. So the first thing that we want to do is identify what is our root. Okay, so we get that from this binomial, and all you have to do is set it equal to 0. It's easy enough to see that test root is going to be -1. All right, now that we have that, we're ready to actually set up our synthetic division using our chart. Of course, you can just quickly draw this by hand. I have it already set up for us. So we have our test root -1, and then in the rest of our first row, we're going to list the coefficients. So looking at our greater polynomial, the one we're actually dividing, we have our coefficient of x to the fourth, which is 3, 3 for the x to the third coefficient, +7 for the x squared. Notice that we don't have an x term, so I like to write, or at least think, plus 0x in my head because we need a placeholder 0 here for our synthetic division. And then our constant term is a -7. So watch out for placeholder zeros and make sure you get the sign for each coefficient. So let's list those in our first row. 3, 3, 7, placeholder 0, and -7. All right, so now we're all set up. We're ready for the process of synthetically dividing. So you always start by bringing down that first coefficient. So we just rewrite the 3, and that's in our row 3. All right, so step 2b is to multiply and record the value. So we're multiplying our root times our row 3 coefficient. -1 times 3 is -3. We record it in our second column, row 2. And then we just add the values in this new second column. So 3 plus -3 is 0. All right, so you can see we're down to step 2D now. We're going to repeat steps 2B and 2C until we get to the end of our setup. All right, so let's do that. It becomes a pretty easy process here. We have the root -1 times our new row 3 coefficient, or value, excuse me. So -1 times 0, of course, is 0. Add that third column. 7 plus 0 is 7. All right, repeat, -1 times 7. So we have that is, of course, -7. Add that fourth column. 0 plus -7 is -7. And repeat one more time. -1 times -7 is +7. Add that final column. We get a 0 as our remainder, so box that. Of course, my diagram already shows that boxed. So we see that x plus 1 does divide equally into our larger polynomial. Okay, I go ahead and I list the point on the graph because at some point you might be graphing that larger polynomial. We know -1, 0 is a point on this polynomial's graph. That could be helpful for your future studies of polynomials. And now we want to see, like, what is the answer for this synthetic division? What's the quotient? And we get that by looking here in row 3. So I like to work from right to left. So work starting at the remainder, working backward almost. And you're using these values from row 3. So the -7 will be your constant term. The 7 is the coefficient of the x. The 0 is a coefficient of x squared. And the 3 is the coefficient of x to the third. So that'll be easy enough to write out. Okay, we have 3x to the third. We don't have to write anything because 0x squared goes to 0 for that next one. Plus 7x minus 7. So that's the quotient for our division problem of those two polynomials. All right, so this method is pretty simple. Once you practice it a couple of times, you'll get used to it. And don't forget those tips on how to avoid some of the most common errors. Good luck with your synthetic division.